Okay. Hello everyone. This is the last lecture, revision lecture. We're gonna do a quick summary of what we've learned, what might be in the exam here. Exam is 2 hours closed, but you can have a calculator. It can be programmed, yeah. If you want to punch the formula into your calculator beforehand, please do. It saves you a lot of time, yeah. Um, Usually I've got about 1/3 or 150 marks calculation type question, and the rest are descriptive. Calculation questions are pretty obviously from module 1 and 2, yeah, and the rest of the module are mainly just descriptive. So anyway, to me, if you listen to what I'm telling you today and also study past exams, you should be easily pass the hurdle. So there is a hurdle on the exam. You have to not only pass the course, 50% of the overall mark, also you have to get 40% of the final exam. If you ask me, knowing you guys and my online student, I think everyone should pass the hurdle. I've never, like most of my courses, they've got hurdle. I only had 1 or 2 students couldn't pass the hurdle in these 3 years we are running the hurdle. Yeah, so don't distress about the hurdle. Stress about the passing the course. Yeah, so if you can pass the course, you should be able to pass the hurdle. Anyway. So start from the first module. You remember we did a little bit of review of error analysis, yeah? We talked about the error propagation, many stuff you've learned. Sorry, I'm shutting the door. Many stuff you knew it already, yeah? From automated that you had with me, from COMSB, geodetic A, yeah? We just put everything together, try to have a good review of what you've known, and we add a little bit, yeah? Trying to give you to think about pre-analysis, yeah? So there will be no star on it in the exam, obviously, so don't distress. We've done the pre-analysis bit, so I'm not going to assess you on any shape or form, but I will assess you on error propagation, yeah? There will be a question about error propagation. Might be similar to what we had past exam, or I might change the scenario, yeah? Doesn't matter if I change the scenario, it's always a station and a few points you want to set up, yeah? So same. Anyway, let's have a look at what kind of questions we can have. So I also can have a question about terminology in error analysis. Do you remember we had a whole section in the first module about, what is circular confidence region, what is, confidence level, what is error ellipse, yeah? So please read through. I always like to have questions from that part for some reason. I'm just in love. Anyway, so there will be a question similar to that. I might ask you about terminology. We had it in the past exams too. If you had a quick look at the past exam, you will see I've had similar. I will have a question like what we had here, for example. I had a station, I want to set out the building, yeah, or a bridge or a dam or something, and then I asked you to tell me what would be using the error propagation formula, tell me what is sigma easting and northing, as well as relative uncertainty, yeah. We had absolute uncertainty, which was for the point. We had the relative uncertainty, which was between 2 points, yeah. So have a quick look. We have working example in the study book, yeah, as well as we've got working example like in your assignment you've done it. We had it in a spreadsheet. So you can have a quick look, and if you still feel uncomfortable or you don't know what you need to do, send me an email. I will explain it to you step by step, or please post in the forum one thing. The reason I ask everyone to post because it might be someone else's question too, yeah, and then you can have a look and say, hey, oh, okay, I've got that problem, so I don't need to study this part, or this is how it's solved. But if you want me to check your solution, don't post it in the forum, yeah. So solution, you don't share your solution to each other with each other, yeah. You can check or collaborate or think together, but don't share it, yeah. What else? So it can be, for example, this type of question. I tell you, what is random error? What is random error, by the way? Anyone remember? Let's test you. We have, systematic error. We have random error, yeah? Systematic error is you forgot something, yeah? You forgot to put the prism constant or something. You didn't measure the height of target very precisely or something like that. So everything is going to be out by a constant number, yeah, or something. If you've got the random error, it is something you cannot prevent. Yeah, random errors is happening no matter what you do. It's like your instrument precision. Yeah, no matter how precisely you measure the distance, there is 2 mil plus 2 ppm error. Yeah, in every distance you measure. We call them random error. Make sense? So relative and absolute, I just told you. Yeah. So these are the stuff I might have from the terminology in error analysis. Have a look, make sure you know. Of course, I don't want you to be word by word. I never want you to be like that. If you show me you understand, that's enough. Even if I'm explaining to you, I'm not very similar to that, yeah? I'm just explaining as I understand it. And that's enough for me. I don't want you to be memorizing. I want you to learn, yep? Are we good? Everyone? Good. So make sure you read everything. So sometimes not only I ask about terminology, I might ask you to draw the diagram, yeah, to come with it, yeah, in terms of circular confidence region, for example. Then you show the arrow ellipse and circular confidence region and how they are different, for example. So when I say draw the diagram where appropriate, or use diagram to explain, I expect you to have diagram, yeah? So if you don't do it, then you will lose mark. So far, so good? Okay, so the other type of question it might be, as I said, about error propagation. This is just explaining what you're doing. To be honest, I won't ask you. I'll probably ask you the numbers, yeah? I will ask you to do the error propagation for me. That can be one example that I give you the partial traverse, yeah? And then I ask you, okay, now tell me how you kind of using the error propagation, explain how you will find the sigma asymptoting and hide for the point, yeah? So which is simply carries the error to that point, station C. This is the explanation. So you need to, for this example, you need to calculate the D first and do the error propagation differentiation here to find out the sigma F in this case, which is the function of number of factors, and then you will go and calculate the sigma Ising and Noising. The good news is I never asked you to do such a thing, yeah, in the exam. Just wanted to explain the procedure for you here, or remind you the procedure. In reality, I usually give you the sigma Ising and Noising formula, and then I give you the scenario and ask you to just punch the number, find the sigma Ising and Noising for me, which is going to be your absolute uncertainty. And then I also ask you about the relative uncertainty, which is similar to, for example, what you had in 2018 or 17, yeah, building scenario. This is building. I might ask you, for example, a bridge, yeah, just 2 points. Do you remember bridge center line, for example? I might give you that kind of scenario. It's same, yeah, don't panic if you see different scenario. In each scenario, you've got a station, you've got 2 points, yeah? You got the bearing and distance from your station to those 2 points. You simply have the distance and bearing, and then you go and have a look at this formula, yeah? You're just punching the number. The only thing I found people doing most of the mistakes coming from, they keep forgetting that to do the sigma d first, yeah? Remember, sigma d can be different for different distance, yeah? It's not like your angle sigma, sigma for horizontal pointing, yeah? So make sure you do the sigma d first, yeah? Sigma for distance, and once you've got it, you just simply come here and you've got the sigma beta, which is your horizontal reading or bearing, yeah? So in this case, what's the sigma beta? Did I tell you? Yeah, 3 seconds, yeah. Another common mistake, people keep forgetting to convert, yeah. Do you remember 3 seconds we have to convert it? Yeah, to radian, that's good. What else? That's it, pretty much, yeah. So you know the magic number to convert, or if you don't, it's what's that? 206. Yeah, you have to divide by that. If you remember that, if not, put it in your calculator somewhere. So put it as a formula so you know how to convert. These are the common mistakes I found during the time I was marking the exam. Many students, they forgot to convert, they forgot to find a sigma distance, or they do it for one distance, they don't do it for both of them. Anyway, once you find them, then it should be easy, isn't it? You just go and substitute all these values and find the sigma easting and northing, yeah? Again, because you can program your calculator, why don't you use that, yeah? Program your calculator beforehand, punch this formula, so you just put the parameter, get the answer. So you can show the answer only, but if you kind of have any mistake, you don't get anything for solution. So I usually ask my student, yes, you can program it, you find a solution by your calculator, but it's always worthwhile to show your step, because if you then have a problem in your calcs, I can give you up to 60 to 70% of the mark for your solution, yeah? And then the rest will be deducted because you had an error. Mind you, if I have to do the same exam, I might have an error. Yeah, we're all human. You might, in the stress, you might kind of put or punch the wrong number. Then I usually ask you, okay, find the absolute uncertainty, yeah, for each point. And then I ask you, now you know, give me the relative uncertainty. When I'm saying relative uncertainty, I might be in north-south or east-west direction. Make sure which one is which one. So if it's north side, you just simply squared and squared some of the northing, yeah. If it's east west, you go for easting, yeah. Are we good? Easy peasy. There you go. I already told you one question, yeah. There is a question like that. Please study. Anyway, as I said, I might change the number, I might change the scenario, yeah. But we always have error propagation. So then module 2, we studied about the standard specification. Do you remember fit for purpose? We talked about the ICSM documents. We had a lesson up on the study desk. Yeah, make sure you do that. I always love that lesson for some reason. So the type of question I might have, again, it can be descriptive. Yeah, what is calibration, for example? Again, make sure you go and read the terminology in that module, because I usually have a question, descriptive type question about error, kind of mix match of module 1 and 2. Yeah, it's not only from module 1 or it's not only from module 2. As I said, make sure you go through the lesson 1 of ICSM. There's usually one question from that lesson, so there are not too many questions. Yeah, do the quiz, get familiar with the type of question. It might be from these ICSM standards. Also for module 2, I usually have 2 questions, or 2 or 3, depends. The other question I'll probably give you is about audit survey type of question, where I give you, this is the uncertainty with the survey, this is the uncertainty with your audit survey here. This is the uncertainty of, for example, paving machine. Can you achieve, for example, in this case, plus and minus 10, yeah, at 95% confidence level. And then you can see, because my survey answer, let's have a look at this together, yeah? We read through and see whether we can formulate this. It's not necessarily this question, but I always have this type of question that I require you to formulate the problem for me, yeah? Which is, as you can see, the solution is only one line. You might say, oh, it's weighted the same as the first question. But as I said, I put more weight on how you formulate that, or whether you do it correctly or not. That is the more important thing. Okay, let's have a look. A surveyor is using the trick heighting method to conduct an audit survey. for pavement formation. So you know how we do the pavement and usually you go and check and see whether it's meeting the criteria or for, I don't know, TMR in Queensland, yeah, in road standards for different states. Let's say we know that the top of the pavement tolerance, by saying that this is like your paving machine error, yeah, there are few intolerance and is about plus or minus 8 mil at 95% confidence level, yeah. Make sure, see how I bolded these ones? I like to change them, yeah, so to see how well you read and whether you understand these are at 68 or 95. If I were a student and I'm reading question like what I'm doing at the moment, just underline, circle so you know exactly, so you don't forget them. Anyway, you assuming that your survey uncertainty is plus or minus 3 mil, this time is at 68, so I know I need to convert, yeah. And your audit has the similar uncertainty of plus or minus 3 mil, yeah? So you have to tell your employer that whatever you're measuring on the pavement thickness or pavement intolerance, whether they're sitting within plus or minus 10 mil. But in reality, can you tell that or not, yeah? The reason I said, if you add those uncertainties using the simple error propagation theory. When I'm saying simple, you don't have to go and use the big formula. Yeah, do you remember we had the simple error propagation when I taught you in module 1? I showed you two different ways. Yeah, simplified version, the long type. Yeah, for this type of question, I don't expect you to go and do differentiation. Yeah, it's just simply square them and add them up. Yeah, easy. So I've got one error regarding the pavement machine. I've got the error regarding the survey itself. I've got the error regarding the audit survey. Yeah, if you add them up, it comes plus or minus 11 mil. So there's no way you can check the pavement using this approach. So what should you do then? It's more than 10 mil, yeah? So I can't really say they're within the 10 mil. Whatever I'm measuring is just rubbish because I've got enough uncertainty to be more than that. So what you need to do is just find an approach to improve your audit survey, yeah? We can't really do anything about the pavement machine, can we? No. Can we do anything about the survey that has been done? No. The only thing we can change is to improve our audit survey, yeah? Be more precise. Then we can say, yeah, then it's good to go. So if we improve it, let's say, rather than plus or minus 3 to plus or minus 2, then we can achieve that plus or minus 10 mil that we are required for the job. Anyway, this is just one example. There are many examples. We've got the example in the study book. We've got the example in the past exam, yeah? Make sure you go and try to formulate the problem for yourself and see whether you can or cannot achieve it. Many times what I found, a student, they formulate, they tell me all the number, beautiful. They forgot to put the comment. Yeah, that's a very common mistake. You forget, you do everything, and say, okay, let's go to the next question. Don't rush. I ask for you comment, yeah? Comment whether audit survey meets. So if you miss the comments, you're already missing, I don't know, 5, 10 marks. Easy, yeah? And it should have been only, yes, it does meet or not. Yeah, you don't want that. Is the easy mark. Are we good?
So you don't want us to explain how you explained it there?
Oh no, this is a long version, yeah? Just do it shortly.
Yes, no.
Yes or no, or does it meet or it doesn't meet? Yeah, that's all, yeah. I just tell you, in here, I try to tell, if you do it precisely, you can actually achieve. That's what I did, not for the exam. Are we good? Okay. What other type of question might be from Module 2? As I said, from ICSM quiz. I usually have a question from that, so it can be like I give you the Travers miscalls and I tell you whether you meet the ICSM standard, or it can be in the past exam, but I had a error ellipses, yeah? I gave you the error ellipses as, 68, 95. The trick for that is, anyone knows the trick? Actually, many students lost mark for that question. It was easy. When you go from 68 to 95 and you always multiply by 1.96 or 2, for the error ellipse, it's 2.45. Not that I don't give, I still gave them 50% for just knowing what they're doing, but they obviously lost another 50 just because they didn't know it's different going from 68 to 95 from the normal standard deviation, whereas for error ellipse we had it in the module as well, yeah, 2.4 something. Or 2.5 if you want to round it. Yeah, you can always round it. Don't worry about rounding. You can just use 2. Don't have to be 1.96, yeah? I give both the same mark. They're slightly different. I don't care about 1, 2 mil. It's just doesn't matter. Let's have a look at this one. This is the example I gave you, the linear misclose, yeah? In here I said, okay, we done the traverse, yeah, using the traditional surveying method, like using the total station. We found that the traverse length was about 1500. We've got the misclose of 20 mil here. Now I'm asking you, is the ratio satisfying the guidelines recommendation? If I've had a question, I usually give you the table, yeah? So don't have to memorize the table. So I simply come here and say, oh, okay, so what's the ratio to start off? Yeah, do you remember misclose ratio, guys? Please, from Sylvain Gay. You have to convert it to ppm though, yeah? Part per million. You simply, yeah, multiply by 1 million in a way. So this is your misclose ratio, multiply, you get the, in this case, it's 13.33 ppm. Do I have anything? So this is 1500. Do I have any? So you can see I have a columns and I've got the, I've got the rows and I've got the columns, yeah? So in columns I've got the ppm and in the rows I've got the distance. So you have to kind of intersect them and see whether you meet the criteria or not. Do I have any 13? No. So you have to use interpolation, yeah? And try to find out whether it's actually within these two numbers or not, yeah? But you have to really interpolate and find. If I can say, you can use the rough estimate. You don't have to go exactly for 30. You can say 15, yeah? If I say 15, would have been much easier for me in terms of interpolation. Even if you do the interpolation, you can see 15 is actually satisfying the guideline, yeah, because this is 15 mil, yeah, is 45, is 10 ppm. So 13 is somewhere here, yeah, somewhere here is 13, you can say 15 is totally fine to go and round up to make the life easier for everyone. And then you can find that is about 20. If you do the, yeah, it's exactly 20. So anyway, you find that it's 20 and then there you go. You know interpolation, you should know. You've done math 1600, yeah? Are we good? Or you can simply divide. If you don't know interpolation, you can say from 15 to 45 is about 30 ppm, yeah? If 15 is 1/6 of that, yeah? Do you agree? So 1/6 of that, and then you can work it out what it should be. Oh, sorry, in this case, I told the other way. You should find this first. It's 20 ppm, and we go 1/4, sorry. And then you divide this by 4, the difference, and then you add to this. Something like that. And then that gives you the exact number. But even if you don't know the exact and you can guesstimate, I don't want the exact number. You can just guesstimate and say, yes, it's fitting there, yeah? It's closer to this side, I can tell, yeah, it should be, yeah. That's all I'm looking for. Is the easy mark, yeah? Even if you don't get the interpolation right, just do the ratio, guys. You get some marks for that. It's just a vague example. Are we good? Okay. So then module 3 was about INS. We explained, how the inertial navigation system is working. We explained the gyros, accelerometers, different type of gyros and accelerometers, yeah. We explained about the navigation process, integration of the INS and GPS, yeah, or GNSS, and we told that what sorts of errors we've got in the IMU itself, yeah. Do you remember drift, bias, all those things? So we explained a little bit about Kalman filter and how it's working. So, which is kind of an algorithm to integrate the GNSS and IMU, yeah. This is the Kalman filter. Okay, what type of question I can have? I either can have different type of gyros, yeah, gyroscope or accelerometers, and ask you to draw the diagram and explain. You should be able to do it. I put the long version here, yeah. In here, I just copy paste, yeah, from the modules. But you can simplify that for yourself, and just like a bullet point of the important thing, yeah. Don't write too much, because I know your time is limited. I don't want you to write me, if you write one page or few sentences and tell me the main points, they get the same mark, yeah? So don't think that I'm really, if you write more, I give you more mark. There's no such a thing. I'm looking at the keywords and whether you understand the concept or not. So, for example, in here I ask about the gyroscopes. Yeah, you remember we had the very traditional gyroscope that always use like a rotating wheel, yeah, that rotate as you rotate the vehicle that is changing, and it tells you the rotation on the XYZ. We had the ring laser, yeah, which is this one. We had a fiber optic which is similar to ring laser. This is the ring laser, yeah. It's a laser going like a triangle tube, yeah. For the fiber optic is a long fiber, optical fiber that is also using the laser, yeah, to measure the rotation. Sorry. My mind went blank. So anyway, the fiber optic, the advantage is it can go up to a few kilometers, yeah. The ring laser is probably the most used gyros in your phone. We usually have that type of gyros. We don't use like a rotating wheel anymore. It's only for aircraft, maybe still they might use it. So are we good? Is it easy to remember? I might use a similar question but accelerometers this time. Yeah, they all had 3 types. So far so good? Easy? Okay. The other question I might ask is about the error sources in INS. Yeah. So what are the error sources? So first of all, something easy to help you to remember the error sources. You know how in ADM we had a constant and scale factor. Yeah. Do you remember that? Similar to that, we have drift and bias. Yeah. Or scale factor in a way. Drift is the constant one, which is like drifting by, I don't know, this much, and by a scale factor is very similar to the EDM scale factor. The difference is for EDM, the longer distance you measure, yeah, is going to be affected most. In IMU, the longest time you're using IMU system, yeah, is about the time, yeah. The longer you use, you might have more error, yeah, is in terms of scale factor. What other type of error? It can be misalignment. As usual, I told you, no matter how much manufacturer tried to put the effort to align all those IMU units for each of those axes, X, Y, Z, or pitch roll yaw, there is always a misalignment between the IMU unit and where the actual axis is going. It can be a noise, yeah, we can have noise issue because it's like an electronic device and it can have a noise. So these are the type of errors we've discussed, yeah. I usually ask for 4 of them or something. Should be easy to remember. As I said, remember EDM, remember misalignment. You shouldn't write word by word, yeah. Tell me what you think. So far so good. So we know what type of question it might be from IMU. Good. Okay. Satellite geodesy. So is the one we've discussed, different system, yeah, INSAR, DORIS, VLBI, very long base. We discussed about altimetry, yeah, different techniques. It's very obvious what type of question I might have. I usually have a question about any of those techniques. Yeah, it can be INSAR, it can be DORIS, it can be satellite altimetry, it can be VLBI, yeah, very long baseline, blah blah. I can't remember all the acronym for that. Make sure you read all through and just summarize how the system is working, maybe pros and cons or something if I ask for. Good. So each of the module, we always have a question, yeah? So there is no module that I say there is no question, yeah? There is no such a thing. Obviously, more weight is on error analysis, yeah? Because this is the theme of this course, so I have more weight on that, which I already told you, 150 calcs, and the rest will be distributed amongst other modules, yeah? It can be 50 or 60 marks or more, depends on the module itself. Okay, for example, do you remember satellite altimetry used to measure the sea surface height? Was very easy, like send a radar pulse, it bends back here, and then you can, if you know the height of altimetry from the ellipsoid, and then you know what was the range satellite measured from the satellite to the sea surface height, you can subtract them and get the sea surface height, yeah? So, see, I usually say, this is talk. I say, describe, give me two applications. Do you remember for each of the system I give you? When I say application, you don't need to explain the application. It's not like your assignment, yeah? It's the exam. You just tell me just few words, yeah? Altimetry measuring the sea level. That's all. That's application, yeah? It can be INSAR, yeah? INSAR is, we again know that how it's working. Anyone remember INSAR? It was very easy. It's trying to measure land movement using the phase shift in a way, yeah? So it's kind of getting measurement during the time, like every, I don't know, 10 days or so. And then it can measure the movement, whether it can be uplift or, it can be sinking. So it can movement of the land can be measured, yeah? Using the phase difference. And we did the exercise. Do you remember we did something with the software, shows us all those phase shift in the area? Due to the earthquake in that scenario, it was like pre and post earthquake. So are we good? As I said, look at my smiley face. I had a reason for that. So I put the smiley face for you, Make sure you read other technique. Yep. Can be the same technique, can be different technique. Who knows? I can't remember what I put, to be honest. So I'm not lying to you. Anyway, you try to reverse engineer me. Okay, so laser scanning, easy peasy. Zenu did a good job, great job actually. He explained what laser scanning did. So it's very easy. I'm pretty sure many of our students, even online and on campus, you're using laser scanning in normal work, yeah? So it's really easy to remember what are the principles, how it's working, what are the criteria. For example, if I want to go out there and try to set up my laser scanning, what are the things I'm looking for in terms of constraint of where I can put my station? Do you remember we had this in the lecture? Like you don't want to put too close to building, for example. Yeah, you're not going to have a good coverage. There is a distance constraint. There are other constraints like reflectness of the objects. All those things can be affecting. So what type of question I might ask? I might have a very simple question like how is working, lah? You remember we had two types of laser scanning? It's very similar to total station, yeah? Time of flight, phase shift, do you remember that? One of them is measuring the travel time to find the distance. The other one is measuring the phase difference, yep? So in each scenario, you always have a pulse going from your laser scanning, here, hit the object and coming back so it can measure the distance here or range. It's very similar to what you have in the, as I said, automated. Do you remember that? Yeah. So it's just a different, slightly different. So anyway, it might be this type of question that I give you. The reason I don't read through the answer is like I wrote it there, so you can read it later, obviously. The other type of question might be source of error, yeah? Like Tell me 4 source of error for laser scanning, yeah? Tell me how reflectance of the object will affect the measurement, yeah? What else? Uh, I might ask you the constraint for the setting up the laser scanning, yeah? A little bit of planning, how do you do that? So this is an example of the accuracy or error you can have due to the environment, surface reflectivity. What else do we have? I asked you to discuss 4 of them, environmental factor, and explain the surface reflectness and how it's affecting your measurement. Good? So one of them, let's see whether we can say instrumental source of error. What source of error you can have? Laser beam divergence, yeah, is very common. Angular uncertainty, again, it can't really measure the angle precisely, yeah. It can be due to the rotating mirror, yeah. It's not really measuring good, or there are some uncertainty with measuring that. For environmental, it can be atmospheric effect, yeah. It's similar to what you've got even in total station, am I right? Like temperature, pressure, they all affect your measurement. And it can be interfering radiation, yeah? So something is kind of influencing your radiated signal or pulse. Very good. It can be all sorts of them. There are lists of them. Make sure you read, understand. So it's been in the past exam. I'm not quite sure whether it's going to be or not. So it might be or might not. Who knows? Believe me, I don't remember. We write the exam very beginning of the semester. All I know is not really surprising. So, close range photogrammetry. We discuss a little bit, we take it a little bit further from what you've learned in photo and remote course, yeah? We discuss mainly about close range, how you calibrate your camera, a little bit of planning and geometry that you need to look after when you do. Mainly we focus on the planning. Do you agree? Yeah, how do you plan a photogrammetry, which we didn't have too much in the other courses we've got. We said we are talking about a high precision network in this. So you're going to really achieve a good accuracy. So how do you do that? Anyway, the type of question I had in the past exam, or might have, is like different type of calibration. We had that even in the photo and remote course. So we have on-the-job calibration where you put the coordinated frame, do you remember, in front of the object. You take a photo of the frame and object at the same time, and then you can calibrate at the same time. So you don't need to do pre-calibration, yeah? You do it on the job. It's obvious from the name, yeah? Sometimes they call it on the side too, yeah? We have a self-calibration, which you need to do it beforehand, yeah? Usually for the type of work we're doing in surveying, we do self-calibration. Why? Because our object is so big. How are you going to put the coordinator frame in front of the dam, yeah? Or in front of bridge, yeah? Is it possible? Which was your assignment question? Did you use self-calibration or on the job? Assignment question 2, bridge. What type of calibration did you use? Self, you can remember? So you do it beforehand, yeah? You do it with the, look, like what we did. For example, you put the targets on the ground, you take a photo, and then you do calibrate your camera and then take it out there and do this. So it doesn't really matter. It is what happened, yeah? Assignment is not really important at the moment. We try to focus on the exam. So in the exam, I may ask you different time. I may ask you to explain. Again, you don't have to write like this. You have to just explain it in your own word, yeah? I might ask about the 6th constraint, which is affecting your network design, yeah? I might ask you to describe any 4 or any 6 or any 5. Depends on how much mark I put on that, yeah? So in here, as some of the constraint you might have is like image scale. It can be a resolution, workspace. You might have some constraint in the workspace. Field of view, visibility. Yeah, it can be obscured. Yeah. What else? Uh, Incident angle constraint is very important sometimes to get a precise measurement using the closed range photogrammetry. Anyway, there's a whole list in the study book. Please go and have a look and make sure you understand them. Good. So these are the type of questions I will ask from this module. I'm not gonna give you the scenario and ask you to do mission planning. It's not like your assignment. I already assessed that bit. All I want you is just show me some of the things we've got already in the study book. So it's not gonna be anything outside the study book, yeah? So if you read the study book, every single solution is in the study book. Except the calcs one, yeah? Calculation bit is not. So you have to really make sure you know. Module 7, we had about metrology, yeah, large scale metrology, which is mostly used in industrial. I know there are limited surveying firms using the metrology, but this is asked by accreditation body that we need to cover that, because even if one or two of you end up working there, we have to make sure you've got enough knowledge, yeah? So we talk about laser tracker, laser radar, different system, yeah? Precise leveling, how we actually measuring the flatness, yeah? Measuring the verticality, and how we probably, what type of target we use. You know, even in your assignment, you had a big tunnel boring machine, and then you were supposed to tell me which system do you use. Yeah, we had different system, and you have to tell me for those parts you cannot really put the target, what do you use, yeah? Those parts you cannot access. Okay, we had what type of question I can ask? I can ask how you actually establish the macro network to be used for this type of job. Yeah, triangulation. We had a whole section of that in the lecture. So it's like a macro geodetic network you build, yeah, and you have to make sure you can get the scale of measurement as well as, you know, the orientation X, Y, Z, yet because there is no coordinates in this case. If you're using, for example, laser system, we can even use the total station for this type of job, yeah? It shouldn't be like you can use your normal total station to do metrology. What else I can ask you? I can ask you about the system, yeah? Easily. So I can ask you about laser tracker, yeah? Explain how they are working, explain the difference between do you remember laser tracking has two different way of measuring the distance, yeah? So absolute and is the interferometric distance measurement. Yes, so explain the difference between them, comment on advantage, disadvantage. This is very common type of question I can have. It can be for laser tracker, it can be for other system. Yeah, make sure you understand them. You can write down for yourself for each system, you know, a little bit of explanation, a little bit of the important thing might be I'm asking you about the differences or advantages and disadvantages. Let's have a look at the laser tracker together. So we said that, as I said, it can measure the distance, either absolute or interferometric or relative distance, using the encoders to determine. This is the example of the answer, yeah? Quickly bullet point all the main points. So first, it's using encoders to determine horizontal and vertical angle. There are two distances it can measure. Yeah. What else? Target are usually the SMR mirror type of prism. So measure the relative coordinates. It doesn't give you the absolute. Yeah. So that's something is important. Unless you actually calibrate it to known points, then you can get the absolute coordinates. Are we good? Yeah. So the difference between the interferometric, which is actually the relative distance. So very first thing you know, this is relative, not absolute, yeah? So if there is any interruption, you obviously have to do it again. So it's really not really friendly in a way, user friendly. It's rapid, yeah? It can move quickly, highly accurate, yeah? Micron level. So it can measure the distance to micron level. Absolute distance is really similar to what you do in total station, yeah? It's not as precise as relative, yeah? But it can it can be either phase shift or time of flight, as we know, yeah. We know phase shift is more accurate in a way. For example, uh, if it's getting interrupted, is not an issue. It's to measure the distance. Have you seen the total station is pretty good, yeah, with measuring the distance. Unless you are putting in tracking mode, then you might have a slightly issue with tracking. Are we good? Easy peasy. And then you tell me advantages and disadvantages, which is I listed some of them for you, just so you know. So this is the type of question I'll probably ask, yeah? It can be any system. Make sure you read. Are we good? Everyone? Okay. Any questions so far? Am I going too fast or do you want me to slow down? Let me know. 2 modules to go. Okay. What type of question we had in module 8? Module 8, Rod did a great job again. He actually came and did the module 8 and 9 for us. Module 8 was monitoring the formation surveying, yeah, about measuring the movement of the structure. Can be the high rise, it can be a I don't know, bridge monitoring, it can be a dam monitoring, yeah. We discuss different techniques you can have. We discuss how you actually set the controls, yeah. Do you remember pre-analysis, for example? It's kind of, that's how you link it back, everything together, yeah. To do the monitoring, you needed to do pre-analysis, yeah. So it's all linked in a way. Although they seem to be separate, but they're not. They actually, there is a theme in the course. So anyway, so we discussed how you actually come and do the, what is the optimum number of controls you need to have, for example, how you put them. For different structure, you might have slightly different planning, yeah? So we also had a little bit of discussion about the geotechnical monitoring instrument, yeah? What else? That was pretty much it. The type of question I might have, there is a table in module A, table 2, yeah, listed all the technique you can use. It can be total station, GNSS, you know, precise leveling, blah, blah, and listed advantages and disadvantages of each of those technology. I had it in the past exam. The answer can be found in that table. Yeah, you should roughly have a look at the table, understand those techniques and what are the pros and cons. This was in 2017, I think. The other type of question I might have, I showed you 2018, I think. I had like a control, yeah, scenario. I don't know, did I in 2018? Or I had the similar? I don't know. We have a look at that. So I'm going to tell you what other type of question I might have. But it can be, you know, how do you set or plan the controls for monitoring, yeah? Even if you look at exactly where you are visual, different control setup for different, it can be a dam, it can be a bridge, or it can be different structure. Have a look at those two. Anyway, it can be all sort of things. These are the main one, I'm telling you. If you go to exam and say, oh, it wasn't the one that Zara taught. This is a revision, guys. I'm not going to give you the exam questions. Yeah, this is not the purpose. I'm just saying what are the most likely type of question. Anyway, module 9 was the last module, was about the high-rise. We had some multi-story thing in construction surveying, yeah, when Shane explained all those measurement and verticality check how you're going to do that. We actually take it a little bit further, yeah, with the high-rise module. I will try to say how you actually monitor, what are the different monitoring system that we need to have for different type of, whether it's multi-story, like mid-rise, high-rise, yes, super high-rise, the techniques are different. We talked about the different like dynamic movement, static movement, you know, diurnal movement, which is happening daily, different type of movement that your high-rise can have, and how you're going to monitor those. Are we good? So that was the main thing we've learned. So if you look at the past exams, I had the very same question that, okay, explain the, briefly comment and explain this type of movement in high-rise, yeah? So long period movement, daily movement, dynamic movement. Long period movement is happening obviously in the long time frame, yeah, and is actually due to the load of the building, yeah. when the load of building is stay there for 10, 20 years, that can create some movement. Can be due to shrinking, for example, I'll give you the example. Our Springfield campus, A block, B block, one of the block is actually shrinking, due to the soil in the area, but it's not shrinking like a meter. It might be 1 mil or 2 or less than a mil in a year, but in long period is actually a lot, so they have to actually, one of the company do the monitoring for our building. So this is long period movement. What do we have as a daily movement? The thermal, don't you think thermal will affect? It does affect. So dynamic movement is something is happening quickly. It can be earthquake, happening quickly, move the building, and then it goes. So it can be like a wind shear, or wind load. It's like if you have a thunderstorm, coming in quickly, moving the building. Solar effect, again, if there is any sudden change. See, be careful. We've got the solar in daily and dynamic. When we say dynamic, it's very quick, 10 seconds to 15 minutes, Can be like a very strong thunderstorm is coming and shaking the building and going, That is categorized as dynamic. So there's a whole table. I'm going to put the section number for your reference if you want to go and have a look. But this is taught, this is the example of the answer I expect you to do. Don't explain too much. Don't waste your time. And then I asked you, okay, for each of them, tell me how you're going to actually check the verticality. It depends on whether it's low-rise, mid-level, high-rise, super high-rise, We have a nice table here that I tried to say. We had it even in construction, if you remember, very similar thing. And in low-rise, you probably use the plumb line, or you level up, if it's only few story. For mid-level, we had a side hole, that we used to transfer our control from, ground to the, level 2 or 3, and then every 5th level or 10th level, you might transfer it, because they block the side hole. You're not going to see all the way through for all the time. And then we have high-rise and have super high-rise. We use GNSS system, we told you the minimum is 3. Usually they use 4, to give them a good configuration, to kind of monitor the real-time changes, using GNSS. This is pretty much the overview of what we've learned, what it might be in the exam. Any other question you would like to ask? Okay, so please don't distress yourself. Study whatever I told you here. Study past the exam. You will pass the hurdle, And then if you want to get obviously higher marks, you have to obviously put more effort. There are always new questions. I don't promise you it's going to be all similar, so I can tell you at least there are 30-40% or more new questions. But when I'm saying new question, it's not really rocket science, For example, I ask about the INSAR, I might ask about altimetry this time, It's not completely new. It's like I change it slightly, Or I ask about gyro, I might ask about accelerometers, something like that. It's not really coming out of nowhere. So far, so good. So let's have a quick look at 2018 if we have any problem or something. So let's see, now we've done the revision, how many of them we actually can answer easily. Everyone can see? Or maybe I open the PDF version here. Come on. Might be better. Come on. Okay. Okay, so see, you've got 2 hours and 10 minutes. Please read that 10 minutes. Start reading all the questions carefully. Underline, circle, and then later on when you come to answer them, you actually know what are the main points, So you read it quickly and answer. It's restricted. It's not, you can have a, in my revision I said closed. By closed, I mean it's not open book, So you can have a calculator, but it can be a programmable, so you can program it beforehand if you like. So that's pretty much it. See, I had this like in 2 years in a row, yeah, I might change the scenario, but as I said, it's always you have a station and you have a 2 points, and I will ask you to have absolute and relative uncertainty. So it's really easy. There is always question like that. So this is the question from ICSM. I told you the two type of question I might have. Yeah, this is the one I told you many students got trapped in converting from 60/80 to 95. This is the one I told you I would expect you to do, formulate the problem for me. Again, be careful about 95, 68%, because when I'm telling you the total station precision, I mean 68. There you go. Okay, are we good? So these are, so far we know. So this is the question I told you. It should be from terminology always, yeah? So have a look. 40 marks, to be honest, is a given mark to me. You all even know it by heart, yeah? So positional uncertainty, easy peasy, yeah? Um, IMU, you don't know, positional uncertainty. Okay, so IMU, I told you, it can be, gyros, accelerometer, 4 different sources of errors, this type of question. I told you there's always a question from satellite geodesy. Here is INSAR, it might be other system here, or it might be the same, who knows. Then I have a question about laser scanning, yeah. It can be how it's working, explain the procedure. It can be the error, environmental, instrumental, reflectiveness of the surface. What else I can ask? It can be about the planning of the, what are the constraints you consider. Code range, I told you it can be about the calibration, it can be about the network design. Yeah, here is I ask you 4. So I did try to underline and bold for you, so you're not gonna miss it, yeah, by any chance. You don't come back and say, oh, I thought it was 3. No, I did bold, underline, and make sure it's clear I want. So it's about 6 of them or 7 of them, I don't know how many. I only want you to explain 4. This is again a type of question I can have from the metrology. Yeah, I ask you want to determine the horizontality and flatness of the industrial machine workbench. What are the optical? Do you remember we had optical method, and we have 2 type of method. Even in your assignment, I kind of helped you by determining which type of method I want to use. Okay, so you have to think what instrument you're using, yeah, for that, and how you're going to do it. I always like this type of question, which makes you to think and show me some of the understanding. From the metrology, I can also have a question from the different instrument that we are using, like laser tracker or GPS, yeah? So again, it can be any of them. Then moving on to monitoring, here is the one I told you, yeah? There are 3 general characteristics of the network, and then we had a separate section for each scenario or structure, yeah? It can be dam, it can be bridge. Here I ask for bridge, I might ask for something else, yeah? So this is type of question we can have. And the HARAS, this is the exact same one I've done for you. But it might be different question, yeah? So because I've got it 2 years in a row. Okay, just kidding. So, no kidding for this one. I'm telling you, it's not going to be the same. Are we good? Cool. So I hope everyone here, I'm pretty sure everyone here passed, just getting a good mark, yeah? I'm looking for AHD. I like that, yeah? Good for you. Okay, so that's it. Thank you for being such a good cohort. I really enjoy teaching you guys, and I hope everyone do well in the exam. We're going to have a Q&A session. I don't know whether you saw my post in the forum. I put it on Friday. I wanted to do it on Monday, but I thought it might be too late. It's better to ask your question early, and then you have a weekend to work on that. But if you feel like we need another Q&A session on Monday, I'm more than happy to do another session. And then you can ask your very last question in the forum. Okay, thanks everyone. That's the end of advance.